Let's see the instantaneous rate of change of y with respect to x. See, as the name suggests, instantaneous rate means rate at a particular moment or at an x. What I mean over here is that let's say I have been given y as a function of x. This was x-axis, this was y-axis. Let's take a graph, any graph I'm taking randomly to calculate this instantaneous rate. Let's say this is the graph. Rate at a moment means let's fix an x naught where you have a value y naught and calculate rate at x naught. But the thing is, average rate was defined as delta y by delta x, which was y2 minus y1 upon x2 minus x1. And over here we needed 2 points. But when we say that we need rate at x naught, we are only given 1 point. We at least need 2 points. Any point I pick, that would not give me average rate, that would give me instantaneous rate between the first point and the second point. So what I do over here is, instead of going it in terms of instantaneous, I'll go it in terms of average only, but the points chosen would be very close. Like one point would be x naught, second point would be x naught plus dx, and add, if you bring a small change in x, naturally expect a small change in y. So rate at x naught is now given by average rate between x is equal to x naught and x is equal to x naught plus dx. Now how does it become instantaneous rate? I'll explain it to you. If somebody says that the average rate, as an example I'm showing you, if somebody says that the average rate between, let's say, x is equal to 3 and x is equal to 3.00 and so many zeros and 1 is calculated. Now for a person, this is average rate between 2 points, but for a layman, those 2 points are almost the same. So this would give me instantaneous rate at x is equal to 3. Similarly, when you choose 2 points very close, then the average rate turns to instantaneous rate, which is actually equal to y2 minus y1 by x2 minus x1, or y plus dy minus y upon x plus dx minus x, which comes out to be instantaneous rate being equal to dy by dx, which is nothing but a way of writing y2 minus y1 by x2 minus x1. So from now, instantaneous rate would be given by dy by dx, which is nothing but y2 minus y1 by x2 minus x1, provided that points are very close. Now there was another fact about it, that the rate can also be written as slope of secant joining initial and final point. The average rate could also be written as slope of secant joining I and F. Consider initial point over here and final point over here and join them, and you'll realize that the secant over here turns to a tangent. If the secant over here turns to a tangent, this instantaneous rate can also be written as slope of tangent drawn to y versus x graph at that point. So these are various ways in which we can define instantaneous rate. Instantaneous rate is also known as dy by dx, or it is y2 minus y1 by x2 minus x1, considering the 2 points to be very close, which finally comes out to be equal to slope of tangent to y versus x graph at that point.